Okay, today's the last bit, investments with regular deposits. So an example of something that fits into this would be superannuation, for example. So it's an annuity investment, and every time you get paid, money gets deposited into it, and over time increases until you retire. All right, so what do we need to know? We need to know what recurrence relations are. So let's have a look at the recurrence relation. Okay, so the recurrence relation, of course, we need somewhere to start. So that's the principal, V naught. How much gets put in at the start. And then the next month's value is this big R, which includes the interest earned, times the previous month's value, plus, that's if it's monthly, of course, depending on whatever the compounding term is, but this value or the next values R times this value plus the deposit that we put in. And so big R is this relationship, which hopefully should be reasonably familiar to 1 plus little r on 100. And little r, of course, is the interest rate per compounding period. All right. And the D is our payment deposit / deposit, whichever you prefer to look at it from. All right. So whether you like to think of it as a payment going in or a deposit going in, either of those is ways of looking at it is fine. And of course the plus there here, the plus meaning it's going up. All right, so let's have a look at a couple of examples. And so I'll do examples in two ways. The first example we'll look at the recurrence relation, and the second example we'll look at financial solver. All right, so here we go. We've got this fellow Elroy, wants to travel. He's got a $1,200, so there's his V naught, and plans to add 50 each month, so there's his D. And the account pays 3% compounding monthly, so that's where our little r comes in. And it's 3%, but it's compounding monthly, so there's per annum there. Compounding monthly, 3 divided by 12 is a quarter, or 0.25% per month. All right, so let's have a look at some calculations using that information. All right, so the first bit, part A, we wanted to know what is the recurrence relation. So it's V naught. We know that's 1200. We know his deposit's 50. We know little r, we figured that out to be 0.25% per month. And so big R then, 1 plus little r, 0.25 on 100. And then when you put that in your calculator, 0.0025 is what that comes out to. So our recurrence relations, we need to know where to start. The next month's balance, in this case, the value after in the next month, is 1. Whoops, forgot a couple of zeros there. 1.0025 times the value this month plus our deposit, which is 50. All right. So there's that. All right, so then part B, let's go back, part B down here. What is this value after 12 months? So value after 12 months, n equals 12. All right, so we're going to use this recurrence relation up here to do that. And so what I'm going to do is use the calculator and use the sequence, the recursive sequence function on the calculator. So here's our calculator in sequence. Already got one in there. Let's get rid of that. All right. So our recurrence relation, if you remember, there it is, this one here, 1.0025 bm plus 50. So 1.0025, okay, we're using A, not V here. AN plus 50. And we're starting it with $1,200. And so now up to fill out the table, there we go. Now my table's only going down to 5 here. This is not very good because we need to n equals 12. So now I always forget which one of these two that is that I've got to use. Yes, there we go, got the right one, this one here. All right, I want to go 12. I want 12, so I'm going to give me n table 12. So that's now going to go down to 12. There we go. Now, you'll notice here, when you look here, there's only one decimal place. This is money, of course, so money should be 2 decimal places. Now, if you click on that, you'll see down the bottom here, there's a whole heap of decimal places now. All right. This one's a bit bigger, a bit easier for us. So $1,844, 81, and then 8 here. So we need to round that from 81 cents to 82 cents. All right, so the value that we have, $1,844 and 82 cents to spend on the holiday. All right, so of course, that's not the only way that you can work these things out. You can do these things on the financial solver as well. So let's do an example now where we're using the financial solver. Okay, so here we go. Judy invests $500,000 at 5.5% per annum. Compounding monthly, she makes regular deposits of $500 per month. What is an investment after 5 years? Okay, so our financial solver, N, that's our number of payments. Now, in this case, we've got 5 years, and because we're talking about monthly, all right, these things are monthly, 5 times 12. So over 5 years, there's 60 payments periods that we're looking at. Interest rate, so in this we don't have to worry about changing it. The financial solver's programmed to do that for us. We just put in the yearly interest rate, so 5.5. Now she invests, so if she invests, you've got to think about getting your signs correct. So if she's she's putting money in. So she put in $500,000. She's also making a payment, so she's also putting in $500. All right, so remembering money is, in this case, is moving away from Judy. So she personally has the money, and then she hands it in and gives it, say, to the bank where the investment is. All right, so compounding periods per year is 12 because it's compounding monthly. The payments per year, again, is 12. She's putting payments in monthly. And so now we go to our financial solver. So into our calculator, let's go to our menu. It's on that. So if yours comes up here and it's not here, go to your second page. Financial, already got some stuff in there. We're going to replace all of that. So we got 60. Now you don't actually have to put in 60. You can go, all right, it's 5 lots of 12, 5 years, 12 months. And then that works it out for you, see? So either way, all right, 5.5% there. She's putting in, so negative $500,000. She's payment negative, so make sure you use this one here. Negative 500. Future value is what we're going to find. It's 12 payments per year, compounding 12 times per year. Future value, so you can either highlight in there and then go to the solve, or you can click on the button next to it, and there we go, 6922292, 29 cents 78. So again, we've got to round this up, so we've got to round it from 29 cents to 30 cents. One more cent on top of 29 is 30 cents. All right, so there it is. $692,292.30. So the amount that she has, 692,292 and 30 cents after 5 years. All right, so that's using the solver. Now, as I've been saying, the key thing about the solver is getting your signs right. So here's a little summary thing here. There we go, financial solver sign convention summary that we've got here. All right, so that's on my website, of course, Physics with Sino, in the further maths area. You'll find this as a downloadable PDF. All right, so just type of investment that you've got that you're using the financial solver for, present value, your payments, your future value. All right, and so depending on whether it's positive or negative in terms of that, but essentially for our present value, if you're taking out a loan, the money's coming to you, so it's plus. For investments, annuities investments, you're putting money in to begin with, so there you it's negative. Whenever you're making a payment yourself, putting money in, it's negative. Whenever you're getting money, it's a positive. And then your future value depends on what's going on as to whether the money there is money that you owe or you're owed that you're getting. Right, so you can download that on the website Physics with Sino in the further maths area. All right, there's also a bit of a review page there as well. Where are we going? There we are. All right, so I think that is about it. And so on your work plan there, this is your exercise 9G questions. And we've now finished this particular financial maths section of our course. So, as usual, have questions, make sure you get back to me and ask about them.